Vectors, Lesson 3. In this lesson, we will learn about addition and subtraction of vectors for parallel vectors and non-parallel vectors. Addition of vectors. The addition of two vectors, vector u and vector v, can be written as the sum of vector u and vector v. The result of this addition is a vector which is called the resultant vector. When two vectors in the same direction is added up, the resultant vector has the same direction with both the vectors and a magnitude equal to the sum of the magnitudes of both vectors. Addition of non-parallel vectors. Addition of two non-parallel vectors, vector u and vector v, can be shown by using triangle law. By referring to the diagram, triangle law for addition of two non-parallel vectors, vector AB and vector BC, the resultant vector is vector AC, that is, vector AB plus vector BC will get the resultant vector AC. Addition of two non-parallel vectors also can be shown by using parallelogram law. Two vectors, vector A and vector B, initiated from the same point can be represented by two sides of a parallelogram, which is the vector AB and the vector AD. Thus, the resultant vector of vector A and vector B is the diagonal of the parallelogram, that is vector AC. Addition of few non-parallel vectors can be shown by using polygon law. By referring to the diagram, start from point A to point B, that is vector AB, then followed by vector BC, vector CD, and vector DE, will obtain a resultant vector from A to E, that is vector AE. Thus, the addition of vector AB and vector BC and vector CD and vectors DE will obtain the vector AE. Let's do some exercises. Question number 1. Find the resultant vector of the addition of the two parallel vectors. The resultant vector of vector PQ and vector RS can be written as vector PQ plus vector RS. B. The magnitude of the resultant vector. Magnitude of the resultant vector can be obtained by adding up the magnitude of vector PQ and the magnitude of vector RS. From the diagram, we can obtain the vertical distance, that is 8 units, and the horizontal distance, which is 6 units. Then the magnitude of vector PQ will be square root of x squared plus 6 squared, as well as the magnitude of vector RS, also the square root of x squared plus 6 squared. Then we will get is 10 plus 10 equals to 20. Question number 2. The diagram above shows a parallelogram OABC. M is the midpoint of BC, vector OA is vector A, and vector OC is vector C. Find the following vectors in terms of vector A and vector C. A. Vector OB. Vector OB can be obtained by using triangle law, which is equal to vector OA plus vector AB, which is OA is vector A and vector AB is parallel to vector OC, which is vector C. B. Vector MB. Since M is the midpoint of CB, that means vector MB is 1 over 2 vector CB, which is also 1 over 2 vector OA. Then vector MB is 1 over 2 vector A. C. OM. Vector OM. By using the triangle law, vector OM is equal to vector OC plus CM, vector CM. That is, OC is vector C, and CM is equal to vector MB, which is also 1 over 2A. Question number 3. The diagram shows vector OP is vector P, vector OR is vector R, and Q divides the PR in the ratio 2 to 3. Find the following vectors in terms of vector P and vector R. A. Vector PR can be obtained by using triangle law, which is the vector PO plus vector OR. Vector PO is opposite direction to vector OP, which is the negative vector P plus vector R. B. Vector OQ. By using triangle law, vector OQ is vector OP plus vector PQ. Vector OP is vector P, and vector PQ is 2 over 5 vector PR. Then vector P plus 2 over 5 vector PR, which is negative P vector P plus vector R. At last, we get the vector OQ is equal to 3 over 5 vector P plus 2 over 5 vector R. Question number C. The vector QM, if M is the midpoint of OR. By using triangle law, vector QM is vector QO plus vector OM. Vector QO is opposite direction to vector OQ, means it's negative 3 over 5 vector P plus 2 over 5 vector R plus OM is 1 over 2R. When we simplify, we will get the vector QM equals to negative 3 over 5P plus 1 over 10 vector R. Question number 4. Diagram below shows a parallelogram ABCD. Point Q lies on the straight line AB and point S lies on the straight line DC. The straight line AS is extended to the point T such that AS is 2ST. It's given that AQ to QB is 3 to 1. DS to SC is 3 to 1. Vector AQ is 6 vector A and vector AD is vector B. Question number A. Express in terms of vector A and vector B for vector AS and vector QC. Question number B. Show that points QCT are collinear. Information obtained from questions are: vector AB is 8 vector A, vector BC is vector B, vector DC is vector 6A, and AS is 2ST. Vector AS. By using triangle law, vector AS equal to vector AD plus vector DS, which is equal to vector B plus 6 vector A. Number 2, vector QC. By using triangle law, vector AQ plus vector QC equal to vector AC. Vector AC is the addition of vector AB and vector BC, which is equal to vector A plus vector B. Thus, vector QC is equal to vector AC minus vector AQ, which is 8 vector A plus B minus 6 vector A. At last, we get vector QC equal to 2 vector A plus B. To show that point QCT are collinear, we can express QT, vector QT as H vector QC. By using triangle law, QT, vector QT equal to vector QA plus vector AT. Vector AT is equal to 3 over 2 vector AS. So we get vector AT equals to 3 over 2 vector B plus vector 6A. Now QT will be equal to QA. QA is the opposite vector of AQ, which is opposite direction. So we get is negative 6A plus 3 over 2B plus 9A. At last, we get vector QT as 3 vector A plus 3 over 2 vector B. Now we write back QT as HQC. QT is 3A plus 3 over 2B equals to HQC, 2A plus vector B. By comparing vector A, 3 equals to 2H, we get H equals to 3 over 2. Thus, QT equal to 3 over 2 QC. We have shown point Q, C, and T are collinear. Q, C, T are collinear with Q is the common point. That's all for this lesson. Thank you.